Well, hello teachers and fellow classmates. My name is Nguyễn Thị Hà Phương and I'm from Group 12. And today our group will represent a project named Deploying Microservice System using Google Kubernetes, Nginx, Amazon Elastic Compute Cloud, Docker, GitLab CI/CD, and Nginx. So our presentations will be divided according to the foundations of our deployment. So my section is the first and focus on Docker and Docker Compose. Then he will talk about the Amazon Elastic Compute Cloud and Nginx with roles part 3. And then Phong will talk about the GitLab CI/CD and Trung will do the Kubernetes. So the goal of our project is like the name of project now. First, let's begin with the core concept container. Well, a container is a lightweight environment that packages an application together with all of its dependencies, including library, configurations, and runtime. Containers provide for important characteristics, which is first the isolation that each container will run independently, the possibility that it runs the same on any machine with Docker, efficiency that share the host OS kernel faster and smaller than a virtual machine, and reproducibility, which is predictable behavior across the environment. And the other characteristic make containers ideal for microservice and cloud-native applications. Next, Docker is a platform that provides tools to build, package, distribute, and run containers. With Docker, we follow the principle that build once and run anyway. So the Docker will contain structured components as Docker engine, Docker image, Docker contain, and Docker hub. Let's see here I have the Docker architectures. You see it contains of three main components: the client, the host, and registry. The Docker client is where the group interact with Docker using a CLI or API. Well, the client doesn't run the containers. It sends command to the Docker daemon instead. So in the Docker host, it is the machine running Docker. It includes the daemon, which build image, manage containers, network, and volumes. And the host will store image and run containers. The Docker registry suggests the Docker hub will store and distribute image. The workflow is client, daemon, host, and then the register. This architecture provides portability and automation at the core of our deployment. Next is the Dockerfile, which defines how we build a Docker image. Well, a Dockerfile is simply a test file that contains step-by-step instructions such as from, run, and copy. And each microservice had its own Dockerfile. The base of the Dockerfile may contain diverse components. The Dockerfile will ensure our service is packing correctly and run the same in any environment. So you see here in our project we have Dockerfile for each microservice like gateway. It had one Dockerfile. In service in out we have 1, 2, and in podcast we have 1. So typically these Dockerfile are the same. The main purpose of us to grow this file is like to build a language Python environment and copy our code and install dependency and run the API server inside the containers. So you see that in the Dockerfile we start with from Python 3.1 3.7 and Slim. This define the base environment using a lightweight Python image to keep our container small and efficient. Then we set the working directory, the workday in app. This ensures all following commands run inside the app folders, which is this, and this. Next, we copy and with two dots, which is evolve copy the entire project into the containers, and then we install the dependency to requirement.txt using no cache die to keep the image small. Finally, we define the start-of command using a cmd unicorn app main app host 000 port 8080. This launched the fast API application using a UI core. So overall, this our Dockerfile. So back to the theoretical base, we have the Docker Compose. Well, so what is Docker Compose? So seeing our system include multiple services, we use Docker Compose to orchestrate them locally. The Docker Compose will allow us to define and run multi-contained application using a single YAML file. So it manages the network volume, service, and dependency and environment variable. And mostly important is start the entire system with one command. And this file service, main service that we use in our system, which is Progress for database, Out API for user authentications, Postcard API for postcard data service, App Gateway to handle client requests, and Nginx to for reverse proxy and SSL certificates. So they all will be defined in our Docker compose.yaml file, and I will show you. Well, first we have DB using the official Progress 17 image, and then we will expose the port 5432 and load the credential from the .env file, and then save data in a persistent volume, which is called progress data. And then the second, we have the Nginx, which use the Journal Nginx robots for reverse proxy and auto SSL is open on port 418 and 443. The malconfigured folders is config.txt, license script, and www. And then the user environment variable for domain, email, and, and depend on the gateway to make sure the backend is ready before the proxy run. Next, we had the out service. So it run the image through Jumbui, with service out through port 8002 and 8000. It load the environment variable through the .env and depend on DB. Then the postcode will also have the similar structure, like have image env and dependency on database like the out, but the map port will be 8003 to 8000. About the gateway, it will use the Jumbui with gateway. An environment will expose the port 8080. It contains the URL pointing to internal service like hero, order, and out, when depend on the out and podcast. All of these services are defined in the Docker compose files, and then when we run the command docker compose of build, the Docker will automatically build and run every service inside the container, creating an internal network for communications between them. So after the setup complete, we can access our system Swagger UI at the link, and let's confirm that all the microservices are connected and running successfully. And thank you for listening. And now I will hand it over to my teammates.
Hello teacher, my name is Nguyễn Thị Châu Thi, and today I will walk you through the deployment diagram of my project. I'll cover 3 layers. First one is client browser, Browse 53, and EC2 and application. I will go through each layer in detail so that you can clearly see how they work together. First is EC2 instance. This instance runs on the Amazon Linux using the T3 microtype, and it's where I deploy the entire application using Docker Compose. The EC2 instance exposes 3 ports: 22 for SSA access, 80 for HTTP, and 443 for HTTPS. The next one is Route 53. Amazon Route 53 is RWS DNS service. It maps domain names to the IP address of server In this case, it is my EC2 instance. In short, when the client user access to the HTTPS client Mirai AI space, the browse 53 tail browser to connect to the EC2 with the IP 327.109 or 31. I create a public hosted zone on the domain Mira AI space where all the A record point to the EC2 public IP address. So when a user accesses to the domain, the request is routed to the EC2 instance where the Nginx handles it. And from here, every incoming request is received and processed by the Nginx, which runs inside the container. So Nginx acts as a reserver proxy in my system, so it's the most critical component in the application layer. It receives all incoming requests from the Mira AI space and listens on to port 80 and 443. On the port 80, Nginx automatically redirect traffic to the HTTPS to ensure the security, and on the port 443, Nginx uses the SSL certificate from the Let's Encrypt and forward the request to the gateway container within the Docker Compose. And the SSL setup is fully automatic using the Chronosaur Nginx search box image, so my system can serve valid HTTPS traffic without any manual certificate configuration. After the application processes the request, the response it will send back through the Nginx to the browser. And now I will show you how I connect to the server. First, I will SSA into the EC2 instance. So they bring a quick snapshot. So all required images are available on the server. So now I will show the key config file. So the Docker Compose define the service container like env, interest environment variable, and the Nginx container. So now I will start the app with the Docker Compose. The container are up and the Nginx now will listen on the two port 80 and 443. And let's quick test the domain to confirm the reserved proxy and SSL. So we can see the HTTP 1.1301 move permanently, and location is HTTPS Mirai AI space. So next, HTTPS, we expect a response from the app through the Nginx. The important part is valid certificate and HTTPS connection. So even if the root route returns the 404 not found, the header will show the HTTPS is valid TLS cert, and the server entering it, proving the route 53 to the EC2 to the Nginx and app pipeline works. And now the server is working. This is the end of my presentation. Thank you for listening.
Hello lecturers and friends. So my name is Phong and today I will give you an introduction to GitLab CI/CD and its variables. So what is GitLab CI/CD? GitLab CI/CD automates the entire software development life cycle through continuous integration and deployment. And CI, developer integrate code frequently. Each integration triggers automatic build and test to detect errors early. And CD, after successful CI, code automatically deploy to staging or production environment. And currently, our microservices have two services: authentication and podcast. So before CI/CD, I will give you a demo about. First of all, I need to log in to get the asset token of microservice. Take this to the podcast and and authenticate it. Okay, so here, so we get a gateway in good health. This is before CI/CD. Okay, let's move to the variables of GitLab. So why we use variables? So because it's security, store sensitive data like password, tokens, and API keys instead of hardcoding them. And flexibility, you can change configuration without modifying source code or GitLab's CI YAML. And reusability, avoid repeating values across multiple places. Workflow control, and control job and pipeline behavior dynamically. This is a variable of our GitLab project. Our project is backend source transcript AI. These are some variables we use for GitLab YAML. Here we have Docker asset token, EC2 host, EC2 perm, EC2 user, and env file. Let's move to the GitLab CI YAML. So let me move to the main. Okay, main branch. So in CI/CD, there are two states. First is build and second is deploy. And variables we use image name is this and tag is the latest. Build and push, this is the first in the pipeline. So the rules is we can run this whenever have a merge request or any change in the main branch. And stage is build. Yeah, here. The first stage is build. Our CI/CD have two stages: build and deploy. The first stage, build and push. Image we use Docker 24.0.6, and so we use Docker in Docker. Script, we use this to log into the Docker, use Docker and build and pushing image. and we build image. Then we push image to the Docker Hub and the registry to store the Docker image. And we building and pushing on services. So as I told you, we have two services, authenticate and podcast. So we search all the directory service name. We have two services. So we build it and push to the Docker Hub and Docker registry. And second is the deploy job. So we only use when have a change in main branch and state is deploy. We use a lightweight Linux is OnPy and latest tag. We install some dependencies and set the rules for this EC2 burn to log into the EC2. So now we deploy into the EC2. We create a script for it. First, we create a doc.env from the GitLab variable as I showed you before in here env file. So we create a doc.env file from the variable GitLab variable. So after we create, then we check again with using grab some this to check if there's any error in this. So this ensure Nginx in your EC2, the same for doc.env. And this is we send Docker Compose and doc.env on EC2. And lastly, we create a script to deploy it. We pull our image from the Docker Hub registry. Then we compose down all the running services. Then we Docker Compose up. Then we delete all the unrunning container to clean up your container, your Docker. And lastly is send a script to deploy on EC2 and SS to EC2 and execute it. So now I will make a little change in the services podcast. Okay, wait a second. Here. Okay, so we will change the API health. So gateway is okay. So now we wait. Let me put it. Okay. Yeah, this is before CI/CD. Good health. Now we change it to the Phong test CI/CD GitLab. Okay. Now we create a new branch. Test CI/CD. Now we commit it. CI/CD. We push it into the repository of GitLab. Okay, all done. Let me go to this. Now we create a merge request of test CI/CD into the main branch. Okay, great. Now you can see a pipeline to running the build and push the first stage in the pipeline, because we have to check if it's build successful or not. So we can wait it, and we waited and before it runs. So if it is build successful, you can merge. You can the merge button will be available here. So wait it for a moment. So this is a job running inside. Let me show you it. Here, this is running. Now it's Docker push into the registry. So it takes some time to, maybe it's almost done. It's around 1 to 2 minutes. Check our super. Okay. All good. Now job succeeded. So now we can able to merge it. Right. The build is successful. Build successful. So the merge is available now. So we click merge. Now it will again run the pipeline that I showed you before. Is the it will run 2 stages. One is build and push, and second is deploy job. There are 2 jobs here. So we have to wait a little moment to run all of this. So it takes about like 3 to 5 minutes. Let's check again. Okay, we log in the same as the first video before. Now copy the asset token to broadcast and run this API. Now it's show the gateway from text, CI/CD, GitLab, and successful. That's all. Thank you for listening.
Hello teachers, and my name is Bùi Đình Trung, and today I want to give you a presentation that why we're using Kubernetes and what is Kubernetes. So for current context, up to this point, our team has successfully automated the process of building and deploying our applications onto an EC2 server. But our application is built following the microservices architectures, which means you have a lot of container, like container for account service, container for inventory service, container for shipping service. But the problem is you just run all of this in the single server, just like monolithic. And to fix this problem, I want to use the multi-server architectures. So when I use, for example, the account service will be in a single server. The inventory service will be in a single server. Then when account service server is died, my application is not crash. Okay, it can be used. The user can be accessed to inventory service, and why I gonna reopen or fix this. So the tools we use here to manage our multi-servers is Kubernetes. So according to official Kubernetes documentation, Kubernetes is a portable, extensible open source platform for managing containerized workloads and services. So for simply, the Kubernetes help us to automatically manage, distribute, and scale containers across different nodes. So how can it do that? So under the hood, the principle of Kubernetes is based on a custom model. So what is custom? Imagine that you have a lot of machines, a lot of servers that can communicate and can combine to create an application. So to combine to deploy an application. So in Kubernetes we call it cluster. Cluster means a lot of machines can work together. You can see here we got a server called control plane, or you can call node for a node here and a node here. This is we got three nodes, and we got two different type of nodes. The control plane here, and two of this node is worker nodes. So imagine that the control plane here is a branch, and two of nodes here is your body, and the branch here manage two of this to run our containers through the pod. So what is pod? Pod is the smallest unit in Kubernetes, responsible for running one or more tightly coupled containers. That means the pods can run many containers. So this is our architectures. We have one control plane manage two worker nodes here, and you can see that in the worker node 1 we are pod running database and the pod running authentication. In pod we not only run the authenticate container, but also we run a lot of the container in this to support the container service. So the special thing in Kubernetes is when this worker node 1 is dead, the control plane gonna notice that the pod authentication and the pod database is not running, and it's gonna find the available nodes like the worker node 2 to reopen two pod. Yeah, that means that my service gonna reopen again when the control plane see that my pod is not running. So here, this is a service that we use for applications we use to deploy, and you can see that we are using Kubernetes engine of Google Cloud, and we use a cluster autopilot. So to connect to the server, you can click to the connect button and get this command. Yeah, and right now I'm connected to my cluster. So let's see how many nodes we got in here. So you can see here the cluster automatically give me two nodes for running right now, and I don't manually create the node. The autopilot of the control plane of autopilot cluster gonna compute and give me exactly the number of nodes that gonna fit my my need. So you can check that there is how many pods in my namespace right now, and you can see that I got 4 pods exactly. Look like exactly what I just give you here. My sample, I got 4 pods for my service. So in here you can create create a pod with this command. This is the name of pod, and this is the image of pod. So because I just created it before, so it's gonna error. Let's change the name of pod. So let's get the pod and see what is running right now. So you can see that I got 3 pods, and the hello world one is running, and the hello world, the pod that I just created before, is still running. And instead of using Kubernetes CTL to manually create pods, we can write YAML configuration file. So you will don't wanna go to delete and create a lot of pods manually. You want to write all of it into a file and just run once. So here I got the deployment configuration file. For example, here I got our service for a fast API, and I define the kind of it, a deployment. I define name and namespace. Namespace is just your workspace, and I define the replicas is the number of node you want, and you can see here the node of my deployment is using the image service authentication like this, and the command to run the code, and the env. So how do the pods communicate with each other? So each pod has its own IP address, and the pods can communicate through this own IP. You can see that, but the IP address of the pods gonna change when it recreated. That means if a pod crashes, we can no longer reach using its own IP. So to resolve this, Kubernetes provide a service which give each set of pods a stable DNS name or a stable IP. So if your post is dead and recreate, it's gonna use one DNS. For example, here I just create the service, Kai service for my pod name out. I just declare selector here, so the service here is for the deployment here, and you can see that we have a type. So here we got 4 types. Cluster IP is for internal communication. Then they cannot access to this cluster, this port. Then the node port and load balancer is expose the IP to public, and they can access to. But the node port is we directly let them connect to, and load balancer we expose this IP through a cloud load balancer. So I recommend you load balancer instead of node port. And the last one we have external name is maps the service name to an external DNS address. So last one for the database, you can see that I don't use the Kai deployment, I use statefulness. So what is statefulness? And let me explain that if you have a port and this port crash, this port die and it reopen, all of your data will be gone. So you need a storage to store your data, and even if your port is die, the data will exist, and the port map to the data. And so you can see that for my database service, for my database container, I use the Kai stateful set instead of deployment. And what is stateful set? So imagine that your port will be reopened, recreate again and again, and your data in this port can be gone. So you have to use stateful set, because the stateful set is the special type of deployment in Kubernetes, and it's used to require persistent data and stable network identifiers. So for example, if your post is die and reopen again, you're gonna use the PVC, stand for the system volume claim to request a storage here, and your application, your port, when it run again, it's gonna use this data. It's run again, it's use the data, no matter how many times it run again. Khỏi nói đi. So now I'm gonna show you how I apply the deployment file to my Kubernetes cluster. So first of all, I'm gonna use this command to connect to my cluster. So you can see that I just in my cluster, and this namespace here includes a lot of my posts, and right now I'm gonna delete it and recreate it and deploy again to show you. So I just deleted my namespace, so I'm gonna create it again. So after create my namespace, we're gonna check to see how many posts in there. So currently in my namespace Microservices, there's no running code. And to before applying this deployment YAML configuration, I'm gonna create an env and secret like this. So this is a name of the secret, and from this env file, you can see that this env file to the namespace Mirai. So I just create that, and the last one is apply this deployment YAML. So you can see that my namespace, my service created, a lot of my service container is created. So let's check. So you can see that some posts is errors and some posts is running. So just run again, and with the flag -w to see the post updated again and again. Oh, right now this is running, and as I say before, the special thing of Kubernetes is if one post is die, it crash, it's gonna reopen again and again. So you can see that here we got an error container, but here the Kubernetes automatically reopen again, and right now all of my service container is running.